will learn the numerical which is based on beta function. So we will solve this numerical by using the definition of beta function and the properties of beta function. So for that we have the integration from 0 to 1, and a function is given, and we have to prove that it is equal to 1 upon cube root of 9 beta 2 comma 2 by 3 comma 1 by 3. Now guys, how to prove this? So before starting with the solution, let us understand the definition of beta function. So here for you I have written the definition. So here for beta we have three definitions, that is number 2, 3 and 4. Out of that, if you see the formula number 2, that is the definition of beta function, here the limit is from 0 to 1. But for other formulae we have limit from 0 to infinity and 0 to pi by 2. Now in our case we have limit from 0 to 1. So we'll see the formula number 2. So it says that if integration is from 0 to 1 and we have two algebraic terms in this format, that is x raised to m minus 1, 1 minus x raised to n minus 1 dx, then it is equivalent to beta m comma n, where this m and n is 1 greater than the power of x and 1 minus x. So guys, in short, we have to convert our integration in this form so that we can say it is equivalent to beta m comma n. So let's start. So for that, first of all, I'll consider our integration as I. So here I'll say let I is equal to integration from 0 to 1 x raised to minus 1 upon 3, 1 minus x raised to minus 2 upon 3 whole upon 1 plus 2x dx. Now guys, to convert this integral in the form of x raised to m minus 1, 1 minus x raised to n minus 1, we already have the term 1 minus x raised to minus 2 by 3. It means we just want the term x raised to m minus 1. Now the question is how to bring that x raised to m minus 1, and for that we will do the integration by substitution. So here we will put this x upon 1 plus 2x as t upon 1 plus 2. So this is a substitution that we are using. See, what are we doing? So here x and 1 plus 2x we have considered, and we are substituting as t. So t will be the variable, so we can get that x raised to m minus 1 term through this t raised to m minus 1, and this 1 plus 2 are nothing but the coefficients of x and the constant. So this 1 plus 2 will give us the constant. So remember this substitution by which we can convert the above integral into the definition of beta function. So guys, by doing this, here we'll get t upon 3. Let's cross multiply it. So here we will get 3x equal to t into 1, that is t plus 2xt. Now let's take all the x terms together. So this will come on the left hand side, and that will become 3x minus 2xt. So 3 minus 2t into x is equal to. So we can say that x is equal to t upon 3 minus 2t. So guys, we got this value. So if you want the different substitution, then you can do the substitution like this also. Here I'll show you that different substitution. You may say that put x equal to at upon a plus b minus bt, where this a and b are the numbers from the denominator. So see guys, here a is 1, so 1 into t is t, and a plus b, that is 1 plus 2 is 3, minus bt, b is 2t. So either you do this substitution, or you may directly do the given substitution, that is x equal to t upon 3 minus 2t, to evaluate this integration. Now we just have to differentiate both sides to get the value of dx and the other terms. So here I'll say dx is equal to differentiation of this right hand side. So on right hand side we have t, so here we have to use u upon v rule. So we'll get dx equal to, so in the denominator we will get 3 minus 2t the whole square, that is the v square. Next we'll write down this term, then derivative of t. So this will be 3 minus 2t into 1 minus t, because this is the u term, and the derivative of this term will be 0 for 3 and minus 2 for minus 2t. Now let's simplify this, and obviously we will be having dt over here. So let's simplify this. This will give us 3 into 1, that is 3 minus 2t, and this will become minus minus plus 2t. So I'll rewrite this upon 3 minus 2t the whole square dt. Now we can cancel this 2t term, so we will get the value of dx as 3 by 3 minus 2t the whole square dt. So guys, here we got the substitution for dx. Now let's check the limit. So limit is from 0 to 1. So when x is 0, see here we'll get 0 upon 1 plus 0, that is 1. So 0 upon 1 is 0. So we will get t as 0. Next, when x is 1, so here we will get 1 upon 1 plus 2, that is 3, which is equal to t upon 1 plus 2. So we can cancel this and we'll get t as 1. So in short guys, the limit remains same. So limit is from 0 to 1. Now we got the value of dx, we got limit, we got the value of x over here. Now let's find out the value of 1 minus x and 1 plus 2x in terms of t. Then we can do the substitution. So let's get 1 minus x. So for that I'll say 1 minus this value of x. So 1 minus x is equal to 1 minus t upon 3 minus 2t. So it is equal to 3 minus 2t minus t, that is 3 minus 3t upon 3 minus 2t. It will give us 3 into 1 minus t upon 3 minus 2t. Next, let's find out the substitution for 1 plus 2x. So that is 1 plus 2 into this value of x. So 1 plus 2x is equal to 1 plus 2t upon 3 minus 2t. So this will give us 3 minus 2t plus 2t, that is 3 upon 3 minus 2t. So guys, we got all the values. Now let's substitute all the values in the integration. So therefore I is equal to, integration is from 0 to 1, limits are same. Next, x raised to minus 1 by 3. So this is the value of x. So here I'll say it is t raised to minus 1 upon 3 and 3 minus 2t raised to minus 1 upon 3. Next, 1 minus x raised to minus 2 upon 3. What is the value of 1 minus x? So this is the value of 1 minus x. This raised to minus 2 upon 3. So this will be 3 raised to minus 2 upon 3. 1 minus t raised to minus 2 upon 3 upon 3 minus 2t raised to minus 2 upon 3. We have dx, and in the denominator we have 1 plus 2x. So what is the value? So for dx we have this value, and for 1 plus 2x we have this value. So when we'll write this value in the denominator, 3 minus 2t will go in the numerator. So we will get 3 minus 2t upon 3, and the value of dx is 3 upon 3 minus 2t the whole square dt. So 3 upon 3 minus 2t the whole square dt. Now let's cancel the terms from numerator and denominator which are same. So I can cancel this 3 with 3. Next guys, here 3 minus 2t raised to minus 1 upon 3 and raised to minus 2 upon 3 will come together and will become minus 3 upon 3, that is raised to minus 1. Next, this 3 minus 2t raised to minus 1 will go in the numerator, will become positive 1, and that positive 1 and this positive 1 will become 3 minus 2t raised to 2, which will be cancelled with this 3 minus 2t raised to 2. So I am cancelling this all 4 terms. Now this term 3 raised to minus 2 by 3 is a constant, so we'll take it outside the integration and only 2 term remains in the integration. So I is equal to 3 raised to minus 2 by 3 integration 0 to 1 t raised to minus 1 upon 3 1 minus t raised to minus 2 upon 3 dt. So we'll take this into denominator, so the power will be positive, so 3 raised to 2 upon 3. And now guys, this is matching with the definition of beta function. So this term is m minus 1 and this term is n minus 1. So if value of m minus 1 is minus 1 upon 3, here I'll write, then inside the beta we always take 1 plus than that, so minus 1 by 3 plus 1 and minus 2 by 3 plus 1 will come inside the beta. So this will become 1 upon, now see here I can take 3 square as 9, so that will become 9 raised to 1 upon 3, and here we'll get beta, this is 2 by 3 and this will become 1 by 3. So guys, if we'll rewrite this term, then this is 1 upon, now 1 by 3 is nothing but cube root of 9 and beta 2 by 3 comma 1 by 3. So guys, here we have proved the question which was asked by using the definition of beta function and the properties of beta function. So I am very sure that you like this video, and if you want to learn the more numericals of beta and gamma function and the other numericals of engineering mathematics, then do log into ekeeda.com today itself, and you can enjoy the more numericals and more concepts of engineering mathematics at the same place. Thank you.